Okay, so while we get the next speaker set up, let me also introduce you to the host for the rest of the day. Prathamesh. Prathamesh is going to host all the talks. That means he's going to introduce all the speakers, ensure that everyone is in check, kick off people off stage and stuff like that. That's Prathamesh from Memory IO. In case you all don't know what Memory IO is, sorry, Memory AI, my bad. See, bad memory. That's why I need to use that portal. Use Memory AI, and that's where he's currently working in a pretty interesting space. So if you want to know more about it, you definitely want to talk to him.
So are we? Everybody is awake now after the first talk, I think. Okay, great. So our next speaker is Prashant Chaudhari. He works at Jombe. He is the head of engineering there. He's a big Game of Thrones fan. So if you want to discuss all the theories about what actually went wrong in the last season of Game of Thrones, you can discuss with him after his talk. And he's also enjoying his side gigs. So we talked about side gigs in Nadia's talk. Prashant here also enjoys side gigs, but his side gig is about parenting. So he's enjoying that. And last year also he gave a talk at Deccan Rubicon. So this talk is going to be next part of that talk. Let's see what he has to say.
Kasagai Pune. Great. So I don't have much of sense of humor. Talk might get boring, so just enjoy what something actionable that I might talk here today. So this talk is about specifically about associations that we define in our Rails apps between models. So about me, my name is Prashant Chaudhari. I'm head of engineering at Jombe. By the way, it's my birthday today, 10th of August. Quickly about me, I'm mostly a startup guy. I've never really worked in a big organization yet. Worked with 3 early stage startups, product builder at core. Most of my work recently has been on scalability, security, and resilience. Most of the work, again, on the coding side happens in JRuby, Node.js, and talking to Postgres and MongoDB all the time. Microservices is something that we have been evaluating for last 3-4 months, and we have made significant progress there using Docker, Kubernetes, and the DevOps tools. Quickly about Jombe, we are the leadership development company of the future. We deliver end-to-end talent assessment and leadership development solutions. So we build products which solve HR problems. We have gamified simulations and solutions, micro-learning-based mobile apps, more than 600 clients, million-plus assessments done so far, 50,000-plus enterprise app users. Quickly about our stack, on the DevOps side, we use DigitalOcean and Amazon for hosting, Kubernetes, Docker for deployments. Backend is written in JRuby, Sidekick, Postgres, MongoDB, Redis. UI is written in Angular, Node, and Vue.js. Some stats about us, 15-plus products, 600-plus clients, serving in more than 40 countries now. And 1 million-plus users have taken our assessments so far across these 600 clients. Yeah, so let's get to the point. So last time here at the same conference, I talked about our thinnest and highly flexible API controllers written in Rails, where we had introduced something called as CRUD actions, which was a module written specifically for controllers in Rails, which allowed us to just eliminate the basic CRUD that you write in every controller. This time, I will be moving on to the models that we write and how defining these models have helped us achieve performance in our products. So while defining any application schema, we try to identify the models that we have in our context or the domain that we are building the product for. And while defining these models, at one point you start looking at this thing called normalization, right? So what is normalization? So basically what we try to achieve by doing normalization is minimize the redundancy and dependency of data. We try to split a large relation or a table into smaller tables and define our relationships between them to increase the clarity in organizing data, right? It also allows us to define the referential integrity or maintain the referential integrity and the consistency of data whenever things get modified or deleted or created. And where there are models, there are associations. It's hardly a case where you must have created a Rails app, you have defined models, but there are no associations between those models. It rarely happens. Right? Typical associations in a Rails model are belongs to, has many, has and belongs to many, has many through. In case of a non-relational database, you define embeds one or embeds many associations. I hope everyone is familiar with all of this, since I'm assuming that all the folks here have done something in Rails. So a quick question. So normalization, right? So how deep you should go when you are talking about normalization? So whether one NF is fine for you, whether second normal form is fine for you, or a third normal form, right? It completely depends on your context, what kind of app you are building, what kind of data it will hold, what kind of things will get modified, what kind of flows you have in the app. It all depends on that. And the greater the depth of normalization that you have in your application, greater is the number of associations that you will have to define across models, right? So maintaining, and why we do this is to maintain referential integrity and consistency of data. So question, in RDBMS, this is fine. I mean, you have to kind of define a normalized schema to avoid referential issues and the consistency. But if you're using MongoDB and normalizing your collections to that level, does that really make sense at all or all the time? Because there is a fundamental difference between a relational database and a non-relational database. In relational database, you don't have a dynamic structure, but in a non-relational database, you definitely have that unstructured data that you can create and store, whether you are really using MongoDB for storing non-relational data. So a lot of people come from relational background, and when they start defining the same schema on a non-relational database, they try to define it in the same way. They try to normalize everything, even in MongoDB's context, which doesn't make sense all the time. So the same question happened to us 3 years back when we were trying to build a product which had unstructured data, and we all had come from a relational background. We were trying to define this app using MongoDB now, thinking that this unstructured database might help us in a different way. And that's where we thought but at the same time, we wanted normalization also to maintain the referential integrity that I talked about. So that's where the question struck, whether we can keep the collections normalized and at the same time denormalized, right? So that's where we started defining something called cacheable associations. So let's quickly watch them in action. Yeah. So I have this Rails app written using Ruby 2.5, Rails 5.2, and I'm using Mongoid here to connect to a MongoDB database. A simple example can be looked at for an e-commerce use case where you have, let's say, categories, you have products, and you have orders that you can create for a particular product. It's a very simple use case that I'm taking right now. So let's look at this category model, right? So a category has a name, some description, and let's say I want to maintain the products count. How many products of this category are there in the database, just to have a cached count here. It's a simple thing that a lot of people use. And a category has many products, right? Let's look at the product model. So a product is simply a product has a name, some price, some description, and it belongs to a particular category. Right? This is a usual way of defining two models which are related to each other in a relational structure where you have a products table and you have a categories table, and you have a category ID on the products table, which refers to the particular category in the categories table. Right? So using this also, you can create a product, assign it to a category, and yeah, I mean, life is simple. But what if you want to actually show the products on your website, right? You are, let's say, building an app now, the mobile app or the web version of your app. And in that case, you want to show all the products that you have in your database to the end users. So, but while showing the products, you also need to show the category name of the product, right? So how do you do that? How do you display the category name as well while displaying the product name? So product name, product price, and let's say description of the product. but at the same time, I also want to show the category. So it's slightly difficult because you'll have to make 2 DB calls here, one to get products and one to get the categories of this product. But if you look at the data really carefully, you will notice that category is something that once gets created, hardly gets modified, right? Have you seen on an e-commerce website where a category, let's say electronics, has changed over time? That electronics word never changes, right? It is never going to change in future also. Does that really make sense then to every time refer to categories table just to get the name of the category while displaying a product, right? That's what struck us, that in our case also there are a lot of such things that we are going to create once and are going to reuse at multiple places, and those are not going to get modified in their lifetime. Then, does this normalized schema really make sense, right? That's where we thought, how do I get the category name along with the product every time I fetch products without referring to the categories collection? Because every time you refer to a collection, it's going to be a separate DB query, right? And that's expensive. So just to quickly show you how this thing works right now. Yeah. So I have this product class. I'll just create an instance of it. So right now, let's say the product has some name, say Lenovo laptop. There's some price. I'll just skip the description part, and let's say I have this category called mobile phones. I'll create a new category, laptops, right? So, and I can put descriptions and products count, but I'll skip that for now. And I want to assign this product to this category, where I'll just set category equal to C, and this is set, save. So if I look at the product now, I'll get this. If I want to show the same thing on a Postman collection, just a minute. If I fetch products, here you can see. Just look at the second model. First one you ignore for now because that's what I want to talk about when I define the cacheable association. So here is the regular product that you create, correct? So where it has a category ID, description, name, and price. And if I want to get the name of the category as well, along with the product from the products controller that I have in Rails, it's really difficult because you'll have to then include that category as an association while converting that product object into a JSON. And we have done that using our CRUD actions module that I had talked about last time, where your API controller can now say, I want to include category also with the product. This will allow me to get the category as a separate object, as you can see at the bottom, where it is including everything, category ID, description, name, and products count. But I don't want everything there, right? Plus, let's see how many queries it is making right now to get the products along with the category, correct? If you look at this API call here, you can see that there is a find call for categories, and then there is a find call for products as well, just to get that product object, category object along with the product. But what if I want to avoid these two API calls? Because I know that the name of the category is never going to change. So is there a better way to define this same association that I have defined here, which belongs to category? Let's try changing it to something like this, which is a custom defined association. I'll talk about it, or explain it how it works. So the new association looks like this, belongs to and embeds one category, right? So here I'm trying to embed the category object, which is in a separate collection, not in the products collection. And I want to cache only name, because there might be a lot of other attributes that are there on the category, but I just need the name to be cached. And let's look at it now. Just reload the console. So I have this same object product. I'll just call set category document right now. This is what will actually happen automatically once you define it and create the object fresh. That same association will also allow you to call this method set category document. Sorry. It's JRuby, it takes time. It's not a regular Ruby thing, so bear with me. I'll just find the last product, and I'll try to call set category document, and I'll save it. Now, if I want to see the products again, I've excluded that include part. And let's look at the API log again. Here, as you can see, the call has become much lighter, where there is just one call to get products. And in the response, I can see ID. There is a category document now, which has just the name of the category, along with the category ID and other things that you want from the product model. Right? So how this is working, right? I'm now able to fetch category name using that category document, which is cached on the product model. How does it work? So what we have done is we have opened up the Mongoid model, and we have tried to define our own custom associations inside a Mongoid base class. So this in particular is the definition of this custom association that we have defined. So what we have tried to do is we have opened up Mongoid document class. Inside that, we have class methods. In class methods, we have this one example that I'm talking about right now, which is belongs to and embeds one. So what this is doing is it is trying to find the association class. That is, in case of product, it is category. The association key is category ID. I'm trying to define what all cacheable associations are there right now on product. I maintain the list of all the cacheable associations that's used for some other use case, but I'm not going to explain that right now. Then I'm trying to define the belongs to association, which is what you used to define. Here is the thing that we need to do, which is defining a new field called association name underscore document. This is the field which will hold the cached object of the category model. And on before save of every record, you are trying to set the category document. Here I am trying to check if the association has changed, whether the category ID of a product has changed. If that has changed, then find the new object, slice the cacheable attributes from that attributes list, and just set those attributes on the association underscore document. In case of product, this is category underscore document equal to the documents of the attributes of the category, which are cacheable, which is the name right now. So this is where it is setting the name of the category inside category document, inside the product record, right? And here I am defining this helper method called set association document, which does the same thing. There is some refactoring that we can do here. So this is the method that we created for belongs to and embeds one. Similarly, we have done caching for HABTM associations as well. So in case your product belongs to multiple categories, you can cache all the category names using has and belongs to and embeds many, this kind of association. So these associations are different from your embeds many and embeds one, right? In case of embeds many and embeds one associations that you write in Mongoid, you essentially don't create a new collection for the embedded model, right? So all the objects of that embedded association are stored in the same parent collection in case of embeds many or embeds one. Here, what we are trying to do is categories is a different collection, products is a different collection, but at the same time, because the name of the category is not going to change at all, I'm trying to cache that name on the products collection, which will be useful for me to do all the querying and reduce the load on the database because I don't have to make separate DB call just to get the category name, right? So similar thing is applicable even for embeds many, and we have done similar thing for polymorphic associations as well, where you can say belongs to and embeds one polymorphic. Even if the association is polymorphic, you can cache it. In similar ways, you can do that in Mongoid. So how does this help is, now, because the name of the category is there on the product, I can query products using category name as well. I don't have to rely only on ID. So in case I have the name of the category, I can look up for products which belong to the category with, let's say, name as laptops. So this is what I can do now, which is possible even with embeds many. So whatever you can do using embeds many and embeds one associations, you can do that now with this kind of association as well. So where category.name, category document.name is laptops. And in case of Mongoid, you can even input an index on category document.name. So even if it's a nested attribute, you can still create an index on this kind of attribute, and your queries will be super fast. Right? So here, again, I'm not making two database calls. It's just a products query where category document.name is laptops. So yeah, so this is the way we have been defining associations in our product that we have been building for the last 3 years. I'll show you how much it has helped us in our app. And to talk about something similar on the active record side. Like, I was wondering if similar thing can be applied to a Postgres database also. And then I started looking up if there are ways to create a JSON kind of a structure on a Postgres table. So that's where I understood that in Postgres now they have a support for JSON documents as well. So that's where I started experimenting it. And so let's say I have created another app which is based on Postgres database. And just let's specifically look at these 3 tables here, where there is a template. Template belongs to a particular category, and a template can have multiple variables from which you can fetch the data. So in this case also, we were able to successfully define the associations. So belongs to and embeds one template category. So template category is again, a category kind of a thing for templates. And I'm again caching only the name of the category here. Let's see how it works in case of Postgres. So this is another app where I have a template object. So if I don't define it like this, usually you would define it in this way, where you say belongs to template category. But the new way of defining it would be belongs to and embeds one template category. The only problem here is, because it's a structured schema, defining fields on the fly is not possible. So the way we defined it in case of Mongoid was by creating a dynamic field at runtime. So here, in case of Mongoid, this is possible because I can create fields which are a part of your model. And these can be dynamically defined. You can even have dynamic attributes in Mongoid. So that's why it's easily possible. But in case of Postgres, if you want to achieve the same thing, you will have to create columns in your table before you define those associations. In case of Mongoid, it's not necessary, of course. So in case of Rails with active record, you just have to create a template. And in templates, you have to add something called as a template category document, which is of type JSON. So if you don't define this column, then it will throw an error that you have to define this column first so that the caching can work. So how it works here also is similar, template dot, let's say, last. So what I have tried to do is I have tried to define template category document, which caches the name of the template category. So let's say I have different templates for sending emails, like there is a password change notification or a sign up notification, and I can customize these notifications for different clients. So in that case, I needed this kind of structure where I can define the categories of the templates that I have, and every client can create different templates for the same category for different use cases. So that's where I thought of caching that name of the category also, so that I can search for templates without using the category ID. template category ID, I can directly use the category name. So now the interesting part is how do you query this template using the template category name. So in Postgres now they have a new way of referring to the fields of a JSON object as well. So you can basically query for a particular field inside a JSON document. So template.where template category document. So there is this special syntax for this now, where I say template category document hyphen name equal to question mark. And let's say I put this name and get the count. You can see that I'm getting the count of templates which belong to this category using the JSON kind of schema as well. So what they are essentially trying to do is Postgres and other databases, they are trying to match up with MongoDB or a non-relational database where you can define similar structure that you can do in Mongoid or MongoDB. That same structure you can define in Postgres as well. So just define JSON types and try putting whatever data you want. That is queryable also. You can also put an index on it, and your queries can become faster. Previously, like before the 9.2 version, this was not possible. But after 9.2, they have added support for this as well. So this is all about the caching of associations. So you have to remember that you should do this only if you clearly know that the fields that you are caching are not going to be modified often. So even if those are getting modified, let's say 5% of the times, it's fine. You can update all the associations that are cached, but if the updates are frequent, you have to avoid it clearly. Right? So let me show you how far down the rabbit hole goes in our case, how deep level of caching we have done to achieve performance. So we have something called as companies, which is the model for our clients. Every company has categories, and inside categories we have content. So content can be of any format like lessons, quizzes, activities, and so on. The micro-learning apps that we build are based on this kind of schema where we have companies, categories, lessons, and those lessons are sent to the users of those companies. So in that case, we create the user lesson, which is an association of a user and a lesson. Similarly, so there is a user has multiple profiles. If the user is a part of multiple companies, then we create different user profiles for each company. And a user can be a manager or a learner in that company. And then we have user lessons, again, inside user profile as well. So what all gets cached on user lesson in this case? And that's how we have defined this caching layer, where user lesson has its own status, whether the user has completed a lesson or not, what was the lesson ID, what was the user profile ID. Then we have cached this lesson document. So a lesson document is an unstructured data which has lots of fields, right? So a lesson has flashcards, questions, and a lot of other dynamic attributes as well. But I just need to cache the lesson name, because lesson once created, right, the name of the lesson is never going to change. So even if it changes, we allow those changes only before sending it to the users. So till that point, user lessons are not created in the database. So till that point, you can still allow updates. But after that point, we don't allow updates to the lessons. So in that case, what happens is I can easily cache lesson document. Inside lesson document, I can also cache the company document. So in case I want the name of the company also cached on the user lesson, I can just cache the ID of the company and the name of the company. And I'm also caching the category documents. Whatever categories this lesson belongs to, that is cached as an array with ID of the category and the name of the category itself. That's it. Similarly, because the lesson belongs to a user profile, I'm caching the user profile document and the user document inside it. So how this has helped us is bye-bye to lookups. We have hardly used lookups in our product to even generate any kind of analytics reports that we want. Faster queries, of course, lesser load on database, and ultimately, a happy DB is a happy app, is a happy user. I would have showed this beautiful analytics dashboard that we have built, which shows how this caching on user lesson or user quiz object has helped us generate analytics at category level, analytics at learner level, analytics at company level, using group counts and everything that you can do in an aggregation pipeline in Mongoid without any lookups. And that has had a major impact on our performance of the app. The cons of this, basically, any change in the cacheable association object needs to be replicated if you really care about that. In case you are okay with that older data, you can still live with it. Duplication, because you are duplicating a lot of data in multiple collections. But MongoDB is built for replication and reliability and availability. So you have to live with that, and you've kind of made that choice because you want to do that. That's it for now. We are working on scaling the MongoDB, production deployments with microservices in Docker and Kubernetes, and also securing infrastructure. So if anybody interested in talking about this with me after this talk or during the lunch, please get in touch. We'd be grateful. And we are hiring. So if the stack matches with you, just drop your resume here. Thank you. Any questions quickly?
Have you created a gem out of this?
Not yet. I mean,
It's actually good.
we can plan for creating a gem if there is a...
Yeah, maybe contribute back to Mongoid.
Yeah, sure.
And apart from that, kind of offbeat question, but since you are working on MongoDB, so have you came across situation like you wanted to add indexes and you have so many fields?
Yeah.
Because MongoDB just supports 64 indexes.
Correct.
Yeah.
We have not reached that level yet.
Oh,
I mean,
okay.
4 or 5 indexes on a collection has been working out well for us for now.
Because we have certain clients
Okay.
who have...
Maybe we can discuss
like,
it
yeah,
in detail
we can
after.
discuss offline.
Sure.
Yeah. Thanks.
We have one question there.
My question is why? Why all this is done when you can simply have these all columns as in that collection? Why you are increasing the total size of each object by adding this additional embedded relationship?
So in the particular
Yes,
example, yeah, sorry, go
So
ahead.
whatever you have done, you can just keep all these as a columns, as a category or name of the company or name of the lessons. It's a simple way of just adding those instead of adding those all relationships, because you are saying that the con says that if you change anything, everywhere you have to go and change it. It's not going to be dynamically.
Yeah.
The same thing can be done in this case also. Then
So
why all this
basically-
additional headache of adding more memory? Because this will require more memory now than the normal thing.
Definitely.
Then why it is done? What is the advantage of over the having a simple columns?
Yeah, so in case of categories and companies, right? So I definitely need a list of companies that I want to show at some place. So if I want to get unique list of companies, I'll have to again refer to that base model, that user lesson. If I'm caching everything on user lesson, I create a company name and category name on the user lesson collection. I'll have to refer to that, which is a big table. Like it's millions of records that I'll have in that table. And if I'm trying to get unique list of companies from that table, it doesn't make sense because I can have that as a separate collection. So normalization as well as denormalization at the same time.
Thank you, Prashant. Awesome talk. We'll break for tea and we'll be back in half an hour. We'll be back at 11:45. Thank you.